People around the world receive its benefits in various forms of products and services. All these are enabled by computer simulation. The third pillar of science evolved from computational mechanics. At the core of computational mechanics is the finite element method, and anyone who learns about it always comes across the name Odin. Change the world with computational mechanics. Dr. Odin's unending challenges. On December 25, 1936, John Tinsley Odin was born in Alexandria, Louisiana, U.S.A. Young Odin's life was close to nature. He would often go hunting and fishing with his grandpa as a coach. At the age of 10, the boy really got into a chemistry kit his parents gave him. During high school, Odin showed strong math performance under the guidance of a good math teacher. An admirer of Maxwell and Einstein, he felt one must study math really hard to become great scientists like them. He still liked chemistry, but followed his father's advice and chose civil engineering as a major in university. In 1959, Odin received a Bachelor of Science degree in civil engineering from Louisiana State University. The computer program he worked on at OSU happened to touch on ideas of the finite element method, and he soon became aware of the big potential of computers. In 1962, Odin earned a PhD in engineering mechanics from Oklahoma State University. In 1963, Dr. Odin joined General Dynamics in Fort Worth, Texas, and did analysis for the F-111 aircraft the company was developing, and also did applied analysis for its size and weight compression and optimization. Here, Dr. Odin had two important encounters: finite element method and a charismatic, competent expert in engineering modeling. Two men worked many hours day in, day out on the finite element analysis and finally completed one of the first general-purpose finite element software programs using the most advanced IBM 700 series machines at that time. Were it not for these arithmetic devices, they'd not have dared to try the finite element method that requires enormous calculations. In 1964, Dr. Odin became an assistant professor in mechanical engineering at the University of Alabama in Huntsville, where he later became a professor. While teaching virtually everything mathematically and having opportunities to work with top NASA scientists, Professor Odin did his own exceptionally profound study and research at the Aerospace Engineering Department. Later, Dr. Odin recalls that in those days, he incubated most of the eggs he later put into one basket, his monumental theories. Inside Dr. Odin, a romantic view welled up. I want to do something that will change the world. He was always ready for a new challenge, and he still is. In 1972, Dr. Odin released a book titled Finite Elements of Nonlinear Continua because there were no specialized books available on this subject, and he thought unseen problems could be identified while writing it. It was subsequently translated into Japanese, Russian, and Chinese. Dr. Odin leveraged his deep mathematical background to further explore his revolutionary approach. Before him, the finite element method had been applied only to solid mechanics. He extended his application to use computers to apply finite elements for simulating nonlinear phenomena such as fluid mechanics. He also mathematically proved errors in approximation and suggested another theory that shows how to correct approximation errors that may occur in the process of digitization of raw data. All these theoretical accomplishments were inspired by his experience in writing the 1972 book. Virtually all subsequent finite element method software is subject to the influence of Dr. Odin's work. In 1973, he became the professor in aerospace engineering at University of Texas, Austin. In the same year, the Texas Institute for Computational Mechanics was established, and it later became the Institute for Computational Engineering and Sciences, ICES. Dr. Odin recruited competent researchers and scientists from around the world as the founding director. Dr. Odin's theoretical and research works began to blossom. From a mathematical point of view, can the integration of solid, fluid, and thermal mechanics be achieved by solving partial differential equations? Can various phenomena that natural sciences deal with be approximated and solved in computer simulation? This comprehensive approach that marries physics, computers, mathematics, and other sciences was named and established by Dr. Odin as computational mechanics. In 1981, the International Association on Computational Mechanics, IACM, was formed to convene experts from across the world. Dr. Odin was elected the second chairman. Current computer-aided engineering, or CAE, which is mostly simulation-based, is the offspring of Dr. Odin's theoretical work. Without his achievements, we could not have seen industry advance this fast to the degree that it is now. Computational mechanics percolates through the whole industry today as a vital discipline that underpins progress in engineering. It enables optimization of manufacturing processes. Manufacturers can deliver higher product quality and safety with less consumption in resources and energy, and through compression of development cost and time. Computational mechanics is further extended to be applied for emerging areas like predictive science to improve the accuracy of simulation-based predictions, using mathematical statics methods to seed the structures of the subject of study. Dr. Odin suggests applying the verification and validation approach to computer simulations to ensure higher quality and more reliable predictions. Theodore von Karman Medal, 1992, from American Society of Civil Engineers. John von Neumann Medal, 1993, from United States Association for Computational Mechanics. And Stefan P. Timoshenko Medal, 1996, from American Society of Mechanical Engineers in Applied Mechanics. He also received the title of the Chevalier de l'Ordre de Pomme Académique from the French government in 1990. Dr. Odin has co-written a book with his pupil, Dr. Noboru Kikuchi, from the Department of Mechanical Engineering at University of Michigan. He is also the author of more than 50 academic books and 500 scientific papers. Physics, chemistry, mathematics, civil engineering, computing, mechanics, and finite element method. All these are indispensable parts comprising Dr. Odin's productive career. Dr. Odin has made one achievement after another through his experiences and absorbs everything he learned. Theory, experiment, and computer simulation. We are getting a blurry line among three mechanics approaches. More people are enjoying the usefulness of computational mechanics, but no one can foresee all possible avenues to be explored for it. There must be another way, a new innovation to contribute to making the world a better place. Disaster prevention, medicine, and new material development. Application areas still has been extending. Simulation will help spark innovations in these and other areas. Challenge for changing the world. There are always new challenges around Dr. Odin.